Okay, let's have a look at timber and bearing. So timber and bearing, there are a couple of things to pay attention to, basically. The first one is when you have a timber in bearing, you got to look at whether your timber is buried perpendicular to grain or parallel to grain, okay, because those two characteristic strengths are different. So for timber loaded in parallel to grain, and you can see right here, I got a OVL that is loaded on top, and that you can see the loaded direction, it is parallel to the grains, right? So in this case here, I will use FC factor, that is the timber compression parallel to grain, and that is higher than the value in the perpendicular to grain. Because fundamentally the failure mechanism for parallel to grain and the perpendicular grain, they're different. So for parallel to grain, you can see the timber fiber is loaded in the same direction. So when you're expecting your timber to be fell, and you would expect your timber fibers, that these fibers are buckling at the vertical direction, compared to where your timber fiber is loaded perpendicular to grain, you would have a crushing of the timber. Your timber fiber gets squeezed, so it gets shortened. So those two are two different mechanisms. So just pay attention to that and just use the correct characteristic values for your bearing capacity. So that's why in NZS 3603 you have the timber parallel to grain, and also you have your timber perpendicular to grain. So those are two equations you've got to use for. Secondly, the other thing is when you have a timber that is loaded perpendicular to grain, you would use a K3 factor right here. So K3 factor in NZS 3603 is very vague. But also it is very unintuitive to get the correct K3 factor. But to understand it, what is K3 factor? So let's have a look at this. This is something to do with the stresses in the timber fiber. And when it comes, you have a wide timber column that's loaded, for example, a column loaded on your timber floor, comparing to when you have a skinny column that is loaded on your timber floor. So those two different loading scenarios would have result in a different K3 values. Why? Because it's for example here, if you have a 125 square timber column, and that's compression loaded perpendicular to the floor, and the timber fiber below here, below the timber column, they are not taking the uniformed load stress. Rather, what they behave is when it comes to the edge of because the timber is so long and so wide, it's such wide, so the stresses tend to spread it out and spread it out to the edge of the column. So when you draw the stress profile, it looks like it's gonna go straight, and it go all of a sudden goes up. The stresses goes up. It's got a heaves and a little bit of flat down, and heaves again and flat down. So this is your timber stress profile under a longer timber bearing length. And comparing to when you have a skinny one, for example here, if I was say 25 squared, so all those timber fiber below the column, they gets mobilized evenly. So you can mobilize more timber fiber under for short bearing lengths. So these fibers more tend to be uniform than those who don't. So when you draw a stress profile, this can tend to be a little bit heavy, just exaggerate it. So it tends to be more uniform. In this case here, you can mobilize more timber fiber under the column, and when you can mobilize more timber fiber, you can mobilize more bearing strength, more strength from the timber to take those compression load. So that's why the K3 factor says that if you have a skinny one, short bearing length, you can increase your bearing strength of your timber compared to when you have a longer bearing length, like for example 150 above, then you don't have any benefit to increase your bearing capacity. So this is basically what it says for K3 factor, and you're going to use it for a situation where you have a timber that is perpendicular to ground. But to me, normally I would just adopt using 1, just being conservative, because for timber 1, for timber design, bearing is hardly govern your member design. It's normally either your stiffness governs or your shear governs. So this is hardly govern your design. And secondly, so this for timber bearing, I wouldn't spend too much time on the timber bearing. Timber bearing is normally okay, but you just do your due diligence check and use as 1 to see whether the passes. Normally it's okay. And when you get a situation where you can't get a pass, then you just look at a K3 factor carefully, whether you can increase your bearing capacity. So K3 factor is a correction factor for the bearing capacity. Okay, so that's the timber in bearing. It's roughly the straightforward one. So yeah, I hope that helps. Thanks for watching.